In this video, we will be looking at composition of functions. Recall that by definition, f composition g is equal to f of g of x, and g composition f of x is equal to g of f of x. So basically, to find f composition g, you'll be putting your g function into your f function. And to find g composition f, you'll put your f into your g. In this example, we're told that f of x equals 5 over x plus 4, and g of x is equal to 2 over x, and we're asked to find first f composition g. So we'll be putting g into our f function. So we'll start writing our f function. Our f function is 5 over, and then in place of x, we'll put our g function, and then continue writing our f. Now to simplify this complex fraction, I'm going to multiply top and bottom by x over 1. So in the numerator, I have 5x. In the denominator, when I distribute this x to the first term, the x's cancel and I have just 2. And then plus, distribute it to the second term and I have 4x. So f composition g is 5x over 2 plus 4x. Alright, our domain, we first need to determine the domain for the g function. The domain for the g function, x cannot equal 0. And then the domain for our composition function, 2 plus 4x cannot equal 0. So 4x cannot equal negative 2. Divide both sides by 4. So x cannot equal negative 1/2. So we have this restriction on our domain and this restriction. So in interval notation, our domain is equal to negative infinity up to negative 1/2. Don't include it. Union, negative 1/2 to 0. Don't include either of those endpoints. Union, and then 0 to infinity. So for our second part, g composition f, we'll be putting f into the g function. So we'll start writing our g function first. So g composition f is equal to, our g function is, and in place of x, we'll write our f function, which is 5 over x plus 4. To simplify this complex fraction, we'll take the numerator and the denominator and multiply them each by x plus 4. So this one will cancel. I have 2 times x plus 4 over 5, which simplifies to 2x plus 8 over 5. Our domain, we need to first determine the domain of f, so we can see for the f function that x plus 4 cannot equal 0, which means x cannot equal negative 4. And then for the composite function, the denominator, you'll notice, never will equal 0. It's 5, it's constant, so we don't have to worry about a restriction on this domain. But we do have to include this restriction. So our domain is equal to negative infinity to negative 4, union negative 4 to infinity.